So make sure you have the deck of cards ready to go. I will come back to it in a bit, but we're going to spend a little bit of time on page 154. And just when I say stuff, like I'm trying to make it easier for you, right? When I add stuff, I would strongly encourage you to write this down because you're going to forget later on, okay? So theoretical probability, I would say that usual, like not based on data or trials, okay? Not based on data or trials, and you can't see that trials part there, right? It's not based on data and trials. So the most common ones for theoretical would be games, right? It could be cards. It could be dice or die. It could be a spinner. It could be letters in a word. Letters in word, etc. So when we talk theoretical, it's usually based on just what's available to you, not on actual trials, okay? So basically everything we've done so far, most of the time was experimental, was based on, right, how many chocolate labs did you have last time, right? How many defective tiles did that company have? It's all based on what actually happened. Now we're going to focus a little bit more on theoretical probability, okay? So in the previous section, we calculated probability based on data samples, right? And so I will just say, I will highlight theoretical here. Theoretical probability, the event will occur based on possible occurrences. So it's based on possible occurrences rather than the total number of trials. Okay. For example, if you toss a coin, there are two possible outcomes, landing on tails, landing on heads. The theoretical probability is therefore 50%. Okay. But you will get instances where they will tell you so-and-so tossed it 200 times, right? And got, right? It's not going to be 50-50 on an experiment. And the main reason for that is sample size, number of trials. So I will also highlight this, and I've talked about it already. Theoretical and experimental probability may differ if the experimental sample size is smaller. However, a large sample, right, the experimental should be close to the theoretical probability. And what's larger sample, right? Performing more trials or experiments. And then, right, like, so make sure you know that the distinction, but I do mix it up sometimes. I do mix them up, and I actually made a worksheet for you to see that in more detail. Okay. And here's our first, this is where the deck of cards is going to come in handy. You're not allowed to have this on a test. You can't bring this in for a quiz or AC, but I will help you to kind of summarize this on a study sheet, right? So let's look at the deck of cards before we answer the probabilities of these ones. And let me zoom out here for a bit. So you should have this in front of you right now. And I will make sure you understand that when all of our games here have a standard deck of cards, meaning that the jokers are not included. Okay, we don't have them in the deck of cards. If you know anything about cards, right, that will make sense to you. But just remember that there are 4 suits. There's a diamond, hearts, spades, and clubs. And I will say this. Each suit, who knows how many cards are in each suit? 13. 13 cards, 13 cards, 13 cards, 13 cards. And that's a total of 52 cards. Okay? So there's 13 per suit. Okay? A deck of cards splits in half when it comes to color. Okay, 26 are black cards, like 2 suits, like the clubs and the spades, right? Clubs and spades, those are all black, right? So 13, 13, that's 26. And the other 26, which is your hearts and your diamonds, right? You've got 26 red. So if I'm talking, right, black cards, red cards, you know that there's 26 of each in a deck. 52 cards total. I already talked about that. Let's hone in. These are called, from here, I should have added this. From, if you go ace is like your 1, right? Ace, 2, 3, 4, all the way to 10. Those are called number cards. Okay. And how many number cards are there? If there's 10 per suit, then 1, 2, 3, 4, there's 40 of them, right? If the question says anything about numbered cards, there are 40 of them. And so the other, if you look, every suit has a jack, a queen, and a king. Those are called face cards because there's a face on them, right? So there's 3 per suit. So 4 times 3, there would be 12 face cards. That's also very important to know. Okay, 12 face cards. And I used to just dive right into cards, thinking everybody knows cards, but it's not necessarily the case, and I don't blame you, right? I remember when I moved, I was 18, I had to redo grade 12, and we did probability, right? Sitting in pre-cal math, right? Probability, I'm like, I don't know cards. I've never played these cards before, right? So that's why I made sure you get to see this before I dive in, okay? And so this is what I would have on my study sheet. Okay, basically I'm going to highlight. I would have that there are 4 suits, right? And that there's 13 cards in each suit. There are 26 black cards and 26 reds. It's probably good to have 52 cards in total, just to make sure you know that there's 52. And then there's 12 face cards. Maybe saying that there's 3 per suit. 3 per suit, right? Every suit, right? Diamond has 3, hearts, spades, they all have 3 each. So if you can somehow summarize that on your study sheet, like, it will help you, right? So like, okay, yeah, I know exactly. I'm not guessing here. I know. Maybe one more thing that I will add. This is in addition to what you already have. There are, if you just want these ones here, there are 6 black face cards, right? And therefore 6 red faces. So obviously it adds up to 12 still, but you can split them up into color as well. Okay. So there you have it. So now obviously for today you get to have it with you. Whatever we're doing regarding cards, you're going to need this extensively today. So let's dive in now into this first problem here, into these examples. Okay. If you draw a card at random from a standard deck of 52 playing cards, what's the probability that you'll have one of the following cards. So I will break this up, right? We're gonna have them separately. So it's not too bad. If you know your deck of cards, like if you have this in front of you, you should be able to do it. So to get a heart, right, like cards of just a suit of hearts. So I'll do this. Probability of drawing hearts. There are 52 cards in total. And how many of them would be hearts? There are 13, right? 13. That's it. Okay. And let's state that as a decimal, as a percentage. You need to know how to do that, right? So 13 divided by 52, oh, it's 25%. So you could have written it 1 out of 4, right? Which makes sense. 1 out of 4 cards would be the cards of hearts, right? Now it's getting more specific, okay? A black jack, right? So it's going to be too tight here, so I'm going to just do this. Out of 52, how many black jacks do you have? Let's go to our deck of cards real quick. And I have 4 jacks, right? But they only want the black jacks. So there'd be 2 cards of those. Only 2, right? 2 possibilities of them being a black jack, right? So we got to go 2 out of 52. Does that make sense what I just did there? How I got the 2? That is the important part. The 52, you will most likely get. It's the top number that is the tricky one. So let's figure out what that is. And these are small numbers. So we'll go 0.038, and I'm struggling. Should I write down 4, 5? What is Mr. Durson going to say? It's going to be a 5 because the 6 bumps that to a 5, okay? And that's 3.85% if you multiply that by 100. So it's a small chance of you randomly, right? It gets harder to get that. Yeah. You will not be given this, but you should have the summary on your study sheet. Go ahead. You should have a summary on your study sheet of what I just highlighted, right? Yeah. And next, a card other than a diamond. What is this saying? It's basically saying, in other words, not a diamond. Okay, not a diamond. So watch what I'm going to do here. Probability, and I will do it. I'll try my best to do a diamond. Right, probably a diamond, but I'm going to put a not on top of that. And we have 52 cards. How many of them are not diamonds? Well, watch what I'm going to do here. I'm going to start with all of them, and I'm going to subtract the number of diamonds that we have. And we have how many diamonds? 13, right? So I take away the diamond from the total, and that gives me 39 out of 52. So then I go 39 divided by 52. Oh, it's 0.75. Who knew, right? You knew. So there's a pretty big chance of getting a card that is not a dime. Yeah. Yes. If it's okay, that's a good question, and I'm going to get you to practice that in a bit. But if it's saying what's the probability of just drawing a 6, then it's 4 out of 52. I'm including all 4s, or sorry, all 6s. Higher than a 6, okay. Yeah, then Yeah, so we're gonna do that as well. So the probability of getting a card higher than a 6, you would have to, right? There's 1, 2, 3, 4, 5, 6, 7, 8 cards times 4, right? So 4 times, yeah, then that's your total. That's your numerator out of 52. Yes. And I will do that. You will practice that today. So if that, I'm gonna add a few here because these ones are, I just have 3 here. So let's go to the next page. Oh, this is not supposed to be there. I'm going to add a question there. This was not supposed to be there. Okay, so let's do a question like that. Determine the probability of drawing a red face card. We'll do that there. And instead of this one, C, cross that off as well. I'm going to say probability of drawing a 5 or a 7. Determine the probability. So let's pause here for a bit. Could you answer those? It's really just a fraction for both of them. If you get that wrong, big deal. We'll just cross it off and do the right answer. Could you answer both of these by yourselves? Do it as a decimal, percentage, and just what would you put down if you had to? Screen here. The probability of drawing a red face card. So allow me to make this really, really clear. You've got 12 face cards, but only 6 of them are red. So if you have that on your study sheet, you're like, yeah, I know how to do this. A red face card would be 6 out of 52. Probability of red face. Right? So that's that. What if I asked you probability of red face not? How many cards do you have that would not be red face? Can you do this in your head? 52 minus 6, right? 46. Both of them add up to 52 out of 52, right? Which is 100%. So there's always, obviously this is our answer, but always keep in mind that, right, not getting a red, there's 46 cards that are not red face. So I go 52 minus 6 essentially to get that number there. So I want you to think of like the opposite of it, okay? Next, probability of drawing a 5 or a 7. How many 5s do you have? There's 4 of them, and there's 4 7s, right? So I have 4 and 4, right? So probability of 5 or 7, that'd be 4 cards and 4 cards out of 52. So that'd be 8 out of 52, okay? And of course, if I said not 5 or 7, you take that 8 away from 52, right, to get that. Let's write this as a decimal just to, I actually asked you to do that, right? 0.1538, which is 15.38%. Okay. Probability of drawing a red number card. So probability of a red number. So you go to your, right? You know that there are 10 for the hearts and 10 diamonds, right? So in total, there's 20 red number cards. Okay, so 20 out of 52. And let's state that as a decimal, 0.3846, which is 38.46%. Okay. So there you go. Now you can go play cards and make money. I'm just kidding. Not going to be able You're not going to do so well with just knowing this, right? Um, Next, let's do just the one spinner, and then I'll ask you to do a few questions on that worksheet with cards. It's all card games. So the spinner below, right? Calculate the probabilities. Spinner is another classic. Okay, it's just a classic. Almost guarantee you to have that on an AC test, quizzes, whatever. What's the probability that the spinner will stop on a star? Right? So probability of star, and just go look for the stars, right? Look for the stars, right? 3 stars out of, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. So 3 out of 10, and that'll be 0.3, which is 30%. Okay? So just count. You have to make sure you count how many options there are, because I do get creative with that, and just make sure. Sometimes it's color, so I write in the color of each section because I obviously can't print in color, so I just write the color in there. So just and then also be careful because I could have. Oh, and George, by the way, George conducted an experiment, spun this thing 200 times. These are the results. Now we're talking experimental probability, right? And so there's the theoretical, which is only based on what you see, based on the options you have. Experimental is based on what actually happened, okay? And so those are not always going to be the same. All right, so I know we've got about 10 minutes, so I want you to try at least a few of them, okay? So go back to the deck of cards, you open it up, and there's that chart where I'm asking you to find the probability of these events happening, okay? For today, just write down the fraction of each of them. Don't do the decimal and percent yet, because you could do this fairly quickly if you know what you're doing. On page 2, fill in the fraction. Don't do the decimal until later, until you're done all of that. On page 2, this is, yeah, of your workbook. This is the workbook, okay? So do that, and I will show you the answers before we go, okay? So make sure you do that. So just add these two at the bottom there.